Today we'll be going through lowest common ancestor of a binary search tree. So given a binary search tree BST, find the lowest common ancestor node of two given nodes in the BST. According to LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. So let's look at an example. In example 1, we are given the binary search tree where if we have the root as 6, then all the nodes on the left of 6 is lesser than the root itself, and all the nodes on the right side of the root node is greater than the root itself. So if we are given P equals to 2 and Q equals to 8, we want to find the lowest common ancestor. And in this case, P equals to 2 is found here, Q equals to 8 is found here. The lowest common ancestor is 6 itself. Now let's look at example 2. We are given this binary search tree and we are given P equals to 2 and Q equals to 4. So P equals to 2 is here and Q equals to 4. We want to find the lowest common ancestor. And in the question, it's also noted that they are allowing a node to be a descendant of itself. So in this case, 2 can be a lowest common ancestor because it can be a descendant of itself. Now for example 3, we have 2 and 1. So 2 is actually the root and 1 can be a child. So the lowest common ancestor is actually 2 itself. Okay, now let's look at the example 1. We have this binary search tree and we have P equals to 2 and we have Q equals to 8. So if we are at the root 6 here, then what we can do is to do some checks based on the value of P and Q and the root value that we are at. So if both P and Q are smaller than the root value, then we want to search the left subtree. Else, if both P and Q are greater than the current node or the root value that we are at, then we want to search the right subtree. Else, we will just return the root node as the lowest common ancestor of P and Q. So in this case, we can see that this root node is greater than P and it's less than Q. So we will just return this value as the lowest common ancestor. Okay, now let's look at another example. We have P equals to 2 and Q equals to 4. So again, we want to check if both P and Q they are smaller than the root value 6, then we want to search the left subtree. And in this case, they are smaller than the root value 6. So we will try to search the left subtree. And this value 2 now is the root node itself. So once we are here, we will do the check again. P is 2 and Q is 4. If both P and Q are less than this node, current node we are at, then we will search the left subtree. And in this case, they are not. So let's check. If both P and Q, they are greater than the current node we are at, we want to search the right subtree. And in this case, they are also not. So we will just return this as the lowest common ancestor for this example 2. Okay, so now let's implement the code. If P dot value is less than root dot value and Q dot value is less than root dot value, then we want to search the left subtree, so we can return lowest common ancestor of root dot left. And we also want to pass in P and Q as the values so that they can, in the recursion or the search, the P and Q value can be compared with the current node. So else if P dot value is greater than root dot value and Q dot value is greater than root dot value, we can search the right subtree. And we also pass in P and Q similarly. Else, we will just return the root itself as the lowest common ancestor. Let's run it. And let's submit. Yeah, so our test case passed, and this is the solution.